And yeah, okay. Now, I know that maybe not everyone here took yesterday's class, but can anyone remind me what is the formula for Fg, the thing we derived yesterday? Can anyone remind me what's the formula for Fg, the gravitational force or Newton's gravitation? Yeah. Can anyone remind me the formula for this? Yeah, gmm over r squared. So, Mamuna, basically, I understand what you're trying to do here, but we're going to be using this gmm over r squared. So if any one of you actually remembers what g is, that's amazing. But just know that we're going to be using g as instead of that whole 4 pi square thingy, right? Because we don't need that. I mean, we may need that in some questions, but this is the general formula. All right, what is the value of g? What is the value of g? Yeah, you guys have to remember that. What is g? Because you're going to be using this a lot in calculations. Does anyone remember g? What is g? Capital G. Gravitational constant. What's the value of it? Exactly. Good job. 6.67 into 10 raised to the power minus 11. That's the value. Great. And finally, what's the Kepler's law? Does anyone know that? What's Kepler's law? Can anyone remind me? What's the Kepler's law? I know maybe you didn't remember it, but you have to know what this is because you're going to be using this as well. Okay, guys, what is Kepler's law? Exactly, t squared proportional to r cubed. And obviously, I'm not going to be asking you how to derive this, but keep that at the back of your brains as well. Okay, that's great. The basics are good. All right. Now, I don't know if the student who asked me the question about the resonance graph is here. If you're here, do tell me. The person who asked me, why doesn't the resonance graph touch the x-axis? I know it's kind of weird I'm suddenly bringing this up, but I actually gave it a thought. I was kind of busy, but if you're not here, then I guess other people can benefit from this. But if you're here, oh, that was you. Okay. Now, you know that on y-axis, this is the amplitude, right? And this is the frequency, right? Now, there's a lot of cases when some people start from here, but we're going to start from here, okay? Now, we're going to start from here. Oh, just a second. Okay, we're going to start from here, and we're going to reach a point, and then we're going to finally decrease, and we're going to stop. Now, okay, at this point, the frequency is 0 and amplitude is 0. This makes sense, right? But tell me one thing. If I suddenly say that, okay, so this frequency is not equal to 0. Let's say this is f max. So the frequency is like really high. So f max, let's say. And I am suddenly saying that, okay, I don't like this. I want this graph to touch the x-axis. What am I saying? I am saying that I have a frequency, but I don't have an amplitude. How is that possible? I mean, give it a thought for a second. What you're saying is that, okay, what is amplitude? Amplitude is the distance from the mean position to the peak position, right? So if I am saying that I have a frequency, right? If I'm saying that I have a frequency, this means I have a time period, and if these two things exist, I am saying that I'm having oscillations. Now tell me one thing. If I have oscillations, is it possible that my amplitude is 0? If my amplitude is 0, I am saying that what I'm saying is that this pendulum is static, it's not moving. But then how in the world do I have the frequency? How in the world do I have the time period? I mean, amplitude is 0. So how in the world do I have the frequency? And I mean, in this scenario, I don't have any kind of oscillations happening. So if you are claiming that you have a frequency, your amplitude should be like at least 1, for God's sake. So let's go back to the graph and just a second. Okay, the graph is here. Okay, that's why I can never say that this thing touches the x-axis at least according to my logic, because if I am saying this, then the thing I just explained is going to happen. I hope that makes sense, Wahaj. If that doesn't make sense, do tell me. And that's why we're not going to touch the x-axis. Yes, you can say that it's very close to the x-axis, but don't touch it because that's going to be logically incorrect. All right, that clears up this. Now we can finally move on to the gravitation lecture number 2. Okay, now, as I just asked at the beginning, Fg is gmm divided by r squared. And I know that we have the Kepler's law as well. Let's keep these at the back of our brains. Now let's make the planets. So I have a big mass here at the center, and I have two small masses, one here and one here. So let's see, we have a green and we have a blue mass. Now I am gonna make a distance. So let's show the distance, the separation from the center to this point, and let's use a different color, and let's show the second distance from this point to this point. And we have two different orbits, so I can say that I have two different orbits. So orbit number 1 and I have orbit number 2. Now I can say confidently that this is R1, and I can also say that this is R2. Right. And I can also say that for M1 and M2, there is a time period 1. I mean, obviously, oscillations are happening. I mean, uh, the orbit exists, so it's moving in circular motion. So I have time period 1. Now, what if I suddenly ask you, find T2? Okay, it's a mini challenge for you guys. You have these two formulas. You just need to show me an expression. How can I find T2? You have this information. You have T1, R1, R2, and you need to find T2. I am gonna give you 2 minutes. Let's see if you guys can find it out. It's very easy. You're gonna use one of these. So I've already given you hints. So let's see who can find it out. So yeah, it's from the center to center. Look, Abdul Wasi, tell me one thing. Did I make the orbit over here or did I make the orbit over here? See, the orbit line is actually to the center. Yeah. Okay, now let's see who can find out that thing, the T2. You don't exactly have to make T2 common, but just make a formula where you have T2, T1, and these values. So you can somehow find T2. Okay, guys, this is the last minute. Okay, so I have only one answer so far. What about the rest? The time is up, everyone. Were you guys able to find it out? If you weren't, that's okay, because I'm about to tell you. But if you were, do share your answer. Okay, was anyone else able to find a formula with 2t, with T2? LOL. Okay, I take that as a no. All right, now tell me one thing. I have R1, I have R2, and I have T1. Now, I also gave you guys the masses, but come on, we have the Kepler's law. I don't even need the masses. So I can write this formula as T squared is equal to KR cubed, right? And you know from physics and math that if you have this relation, you can create a relation between R1, T1, R2, and T2. So what I'm going to do is, okay, now let's say that this relation is for T1. I have T1 here, and I have R1 here. Now what I'm going to do is, I'm going to do the same thing, but for R2. So T2 squared is equal to KR2 cubed. Now, what if I suddenly say that I want to divide these two? Now I'm going to divide these two things, and KK is going to get canceled out, and I'm going to get T1 squared divided by T2 squared is equal to R1 cubed divided by R2 cubed. Come on, guys, this was easy. Now, if you understand how this thing works, you don't even have to memorize this. But if you don't, then you have to remember this. Does this make sense for those who were not able to solve it? Does it make sense? If someone asks you in the paper how to do it, will you be able to do it? Okay. Now note this down, and I'm gonna erase this. And if anyone has a confusion, you can always ask. So yeah. Okay, so when you're done noting this down, tell me because I want to erase this. Okay. All right, so I am clearing this up. Now, I'm about to tell you something a bit different. When I was learning this chapter, I kind of had a little confusion. I know it's kind of weird, but I hope no one has this confusion. I had this weird confusion about G and FG. I was confusing G and I was confusing FG, right? I was confusing these two things. Now, the thing is that this thing, right, this is not a force. This is acceleration. You're not supposed to note it down. This is just a general thing. This is the acceleration, and this is the force. Now, maybe if we were not talking about gravitational fields, we would say that this force is W. But since we're talking about space and planets, we're not going to use W anymore. Now, let's get to the point. I'm about to create a formula with G, Fg, and M in it. Now, I know that F is equal to ma, right? That's the general formula. Now, what if I say I want to find out a formula where I have Fg and I have the acceleration? Now, if I have Fg and I have m is going to stay the same. But instead of this a, I am going to put the g because that's the gravitational acceleration. Because now this force, this is not just any force. This is the gravitational force. So if you're talking about the gravitational force, your acceleration should also be the gravitational acceleration. So I can say that g is equal to fg divided by m. And what is m? Okay, I'm about to make a little diagram, and I would love you guys to answer me. Let's make a little star here. I mean, let's make a planet, and let's make a small satellite. Now the satellite is going to be like this. Okay, this is our little satellite. Let's move it here. Okay, it's not moving. Let's make a little satellite here. Okay, this is a little satellite. We're going to make it like this. And this is big M, and this is the small m. And let's make a little orbit. And this is going to be R. This is the separation between these two. This is R. Now, I have a question. Can anyone tell me, in this formula, which one of these masses is here? I mean, I have made this as big M, but let's say both of these are M. Both of them are M. Which one of these masses is going to be here? What do you guys think? Which one of these masses is going to be the one which I have included in this formula? Is it going to be the smaller mass, or is it going to be the big small? Okay, that's amazing. In case someone's wondering why, well, that's because this Fg is the force caused by this on this mass, right? That's why this is the M. So when you have a force and you have the G, these two belong to this, but this M, this is the M on which these two are acting. And that's why it's going to be the other M. Okay? Now, let's remove this and let's write it down. Okay. Now we're going to specify that this M is the small mass. Mass of the moving object. Mass of the moving object. So don't forget it. Now, I have the formula Fg is equal to mmg over r squared. And I have this new formula. Oh, you didn't get it? Okay, Pakiza, look. Let me explain. Okay, W is equal to mg. Look, W is the weight, right? But this weight, look, W is the weight, right? So this means that if I have a planet and I'm the person standing on it, now this is a bit different, but pay attention. This is G. This G belongs to this planet, right? And this W, this is the force. Now tell me this, Pakiza. Is this W, is this the force caused by the man, or is the force caused by the planet? We know that W is a force, right? W is a force. Now, Pakiza, it's a question for you. Is W a force that is being caused, that's being created by the planet, or is this force, or does this force belong to the person? All of us know that this mass is the mass of this person, but we also know that G is the G that belongs to Earth. Now, does this thing belong to the man, or is this, is this thing being caused by the Earth or by the man? Pakiza, a question for you. Please answer this question. Exactly, by Earth, because, obviously, no, Eliza, this is W. Okay, this is the weight of the man, but W is a force, right? This is the force. Okay, if this was the force of the man, wouldn't it be like this? The man attracting the earth, but that's not the case. The man is not attracting the earth. The earth is attracting the man. So this force is being caused by the earth. If you don't believe me, well, if you're not on the earth, if you're in space, if you are in space and we don't have earth, okay, let's say we are in space and we don't have earth, you wouldn't have G, you wouldn't have W, you would just have M. But since we are on Earth, this force is being caused by the Earth. So just like this, in case of gravitational fields and circular motion, this M is always the M that's the other mass, because I know that this Fg is caused by the bigger mass. Otherwise, why in the world do I always show it like this? Why do I make Fg like this? This doesn't mean that this ball is acting. This doesn't mean that this little ball has a force, this little planet has a force towards the planet. No, because we know that gravity is a force of attraction. By the way, never forget it. Gravity is a force of attraction. So if I'm making an arrow like this force is caused by this big mass. And this G is also caused by the big mass. That's why. Okay, now I have small m, I have Fg, and I have G. I'm going to substitute this thing into this, and I'm going to find out, I'm going to derive a new formula. G is equal to mmg divided by r squared, finally dividing it by m. If I write it down in a different way, it's going to look like this. mmg divided by mr squared. And I know that mm, they're going to get canceled out. And I'm going to get g is equal to mg divided by r squared. Now, in this formula, this mass is the mass of the bigger planet. This mass is the mass of the bigger planet. So let's write it down. Mass of the bigger planet star, bigger planet or star. Because the big M is always the bigger mass and the small m is always the smaller mass. And this formula is called the inverse square law. Inverse square law. Why? Because we know that m and g are constant, and I can say that g is inversely proportional to r squared. So the larger r I have, the larger my radius, the smaller my g. The lesser my radius, the greater my g. So I hope no one has a confusion here. If you do have a confusion, you can ask me. And this r is the radius of the orbit. Just like, I mean, it's the same r. So note it down, and when you're done, tell me. And if you have a confusion, you can ask. Okay, that's great. Okay. Memuna, please specify which part again. You're confused on how did I get this? Okay, I'll tell you this. Okay. Fg, okay. G is equal to Fg divided by M. You know that, right? And you also know that Fg is mmg over r squared. What did I do? I literally just put this thing in this, and that's what I got. I mean, look, Fg, Fg. Now mm, they get canceled out. I just did this just to show you, just so that you don't get confused. So mm, they only get canceled out, right? So they're gonna get canceled out, and yeah, I'm gonna get mg divided by r squared. That's it. So yeah, no problem. I'm clearing this, and we have 7 minutes left in this meeting. So after that, we're gonna switch the meetings. Anyway, let's start the inverse square law. Now, I just introduced you to the inverse square law. And we're gonna make a graph. We're gonna make a graph of G and of R. Let's use a black color. Let's move this down. And let's use this arrow. Here we go. We have R and we have G. Let's make a dotted line here. Now, why am I making a dotted line? Well, because this dotted line is the SOP, the surface of planet. Now, according to this formula, we know that there's an inverse relation, right? Let's start our graph from here. So you know that inverse graph, what do inverse graph look like? Is it going to be a straight line? Is it going to be like this? Or is it going to be like this? What do you think? Which one of these am I going to get? 1, 2, or 3? Come on, guys. What does an inverse graph look like? Is it the number? Is it 3? Is it 1? Is it 2? I mean, yeah, just tell me the number. I know it's exponential. Yeah, it's 3. I'm glad you know that. Now, we have 3 here, but you should be asking me, why? Why did I start from here? Why not from here? Isn't that where the graph starts? Well, because it's different. It's different inside the planet and it's different outside the planet. Okay, what do you guys think? What is my graph gonna look like within the SOP? SOP means surface of the planet, and this means beyond the SOP. Beyond the SOP. Okay, you guys have 2 options. Is it gonna be 0? Is it gonna be constant, or is it gonna be like this? Which one do you choose? Do you choose a straight line going up you choose a straight line, like a constant, or do you say it's 0? What do you think? How does G vary inside the planet? Okay, we have several answers here. And Anika, your answer is right. It's a bit confusing, but that's just how it is. This is what it looks like inside the planet. So if you start from the center, it's going to slowly increase at a constant rate. And the surface of the planet is the peak. This is the peak point. And if you move away from the surface of the planet, it's going to decrease exponentially, right? So this means that this R starts from here, right? Obviously, I mean, if I say that G and R square, they're inversely proportional, this means that this R starts from here. Because if it would have started from here, then it should have been like this. Sure, Wahad, sure. No, it shouldn't be the max. Now, as I said, as I am about to say, there's a lot of reasons behind it. But inside the planet, your G is like this. So let's start from the beginning. I mean, I'm summarizing it. I got this formula, inverse square law, G inversely proportional to 1 over R squared. But when I say this, I am saying that my G, it starts from here. I am comparing from the surface of the planet. And if I go from here, if I move away from here, I will know that G is 1 over R squared. But I did not consider what's going on inside the planet. Now, I'm not supposed to tell you this in A level. In fact, I don't know myself, but it's just a fact. Inside the planets, your gravity, I mean, your gravitational acceleration is like this. It increases at a constant rate. So you start from 0, you make a straight line. This means that at a constant gradient, m is equal to constant. So your gradient is constant. And that's why you get this straight line. So Keith, your question, at the center, shouldn't G be max? We don't, I mean, both you and me, we don't have any knowledge of what's inside the planet. So how can we say that at the center, G should be the max? Exactly. At the surface, your gravitational field strength is max. And basically your G is max. Okay, I hope this makes sense. And that's why we're going to get this graph. So whenever you're doing these kind of questions, you are always going to have to differentiate between these two things. You're going to have to show that within the SOP, it's a straight line, but beyond the SOP, it's like this. I hope this makes sense. And okay, if someone asks you, what is this R? So if I start from 0 and I show this, then this thing right here, this is the radius, this thing. This is the radius of the planet, right? This is the radius of the planet. Okay? By the way, at this stage, we are not supposed to know this, but right after it, I forgot to tell you, I will actually do a little derivation, and we're going to prove why inside this. So all of you know that when I have a straight line here, I am technically saying that G is proportional to R, right? And I know that here, G is inversely proportional to R squared. We're going to prove this later, right after this. I forgot to mention you that. Okay, so Anika says, can you repeat the reason behind beyond the SOP curve? So Anika, just a while ago, I derived this formula. Did I not derive this? Did I not derive this, right? So you know that G is inversely proportional to R. So it's going to be an exponential curve, right? It's going to be an exponential curve. So this is my reason, right? This is my reason. The center of the planet, 0. That's the center of the planet. We're starting this graph from the center of the planet. So this 0, this is the center of your planet. I hope this makes sense. That's the center of your planet, okay? Now, I should have told you this before. A level is proof and logic. So we cannot just say that something is a fact. Apologies for that. So let's prove why inside the planet G and R are proportional. Now, let's make a circle. This is our planet, and we have the radius. So this is the radius. Let's represent it with a capital R. Now, there are some assumptions that we're making here. This is very crucial. In A level, we make a lot of assumptions. Okay, so if in the they can even ask you in the paper, what are the okay? Oh my God, thanks for reminding, Sabina. So guys, we're gonna have to end this meeting right now. Thanks for reminding. Let's continue this in the next meeting. Okay, I am sending the link again. See you all in the next meeting. All right. Sorry. Okay, let's move this thing here now. Okay, since we are talking about density, can anyone remind me what's the formula of density? I mean, it's a basic concept, unless you guys have forgotten basics. Can anyone remind me what's the formula for density? Yeah, mass divided by volume. So density is m divided by v, right? And if I represent m, it's going to be, rho v. Now, I know that there's a formula for volume. Can anyone remind me? What's the formula for volume of a sphere? We're not talking about circles, by the way. This is a sphere. This is 3D, by the way. LOL. So yeah, what's the formula for volume? Exactly. It's 4 by 3 pi r cubed. Now I have this formula for mass, and on the other hand, I have this very interesting formula for G, which we just derived a while ago. And let's use a large letter for R because it's the same R here. Now what I'm going to do is I'm going to place this M inside, I'm going to substitute M into the formula for G. And I'm going to end up with G is equal to G rho 4 by 3 pi R cubed. And we have R squared down here. And we know that if we have an R here and we have an R above, I can cancel them out, right? So let me cancel it out. So R and this. So we have R left here. Now G is going to be equal to 4 divided by 3. And I have G rho pi. And I finally have R, right? Now, there's something very interesting that I have to say. By the way, I hope all of you know that we're talking about the inside of a planet, right? We're talking about the inside of the planet. So this R, we also assume that this is this R, right? Now, we know that 4 over 3, this is a constant, this is a constant, this is a constant, density is constant. Now, if I didn't assume that Earth has uniform density, would I have been able to say that rho is constant? No. So that assumption was crucial. So I know that this is constant and this is constant. So this whole thing, this is constant, right? And whenever we have a constant, I can say that G is proportional to R. And that's why inside the planets, G varies linearly with R. So if someone would ask you what's the formula, what's the graph for G and R inside the planet, inside, the surface, this SOP, inside the SOP, the surface of the planet, it would be a straight line. So never forget it. It may come, it may come. I have never seen the question. Maybe I have seen, maybe I forgot, but it can come in the paper. So keep this at the back of your brains, right? I hope if anyone has a confusion, you can ask me. This is why inside the SOP, the graph of G and R looks like this. Okay, does this make sense, everyone? And once you finish noting this down, tell me, because right after this, we're going to be doing something, a question, basically, something really cool, finally. Yeah, 3D means, I mean, 1 second. Yeah, that's 3D. I'm just saying that this is not a circle. This is a sphere, right? Let me write it down in a better way. I mean, it's not a physics thingy. It's just something that, you know, I wrote so you guys keep at the back of your brains that this is not a circle. This is a sphere, right? A sphere. Okay, I am about to erase this. If you are done, I am gonna clear this up. Okay, can I clear this? One, I mean, I'm not gonna do a countdown. Okay. All right, so I assume that everyone is done with this. I am gonna erase this now, okay? Clear. Okay, now, we've done a lot of concepts. I think it's a perfect time to test your knowledge. It's a pretty tricky question, so get ready. But for those who like physics, it can be fun. So let's write the question. Let's use black for the question. Now, mass of the Earth. So mass of Earth is 81 times mass of Moon. And radius of Earth is 3.7 times radius of Moon. If gravitational field strength of Earth is 9.81 ms squared, what is the gravitational field strength of Moon? Okay, it's a pretty question. It's a pretty tricky question. So I'm gonna give you a little while when I see that when I see that some of you, like a decent amount of you, have done the question, I will start explaining. Okay, so good luck. Uh, Make sure you ace this. Do it correctly. Okay, I'm turning off my mic and good luck with the question. Okay, I see one of you has done the questions. I'm obviously not going to tell you the correct answer because I want to hear an answer from everyone. So if you've done, that's good, but always try to, I guess, check it so you know if you are right and all. But yeah, if you're confident it's right, I guess that's kind of fine. Okay, everyone, I'm gonna give you 2 more minutes. So yeah, I want an answer from everyone, even if you think it's wrong, even if you think you messed up. Okay, so last 2 minutes. It's 17 minutes right now. When the screen, I mean, when our meeting time is 19 minutes, that's when I will ask you. All right, guys. 20 seconds left. So, I mean, I gave you a lot of time and I have some answers from you guys. We have 15 students here. I mean, 16 participants, but since I'm here as well. So 15 students and 1, 2, 3, 4 answers. Where are the other 11 answers? Come on, guys. Time is up. I want an answer from everyone. Come on. How many students we have? I mean, I just said 15 students. And I have 1, 2, 3, 4, 5 answers. What about the other 10? Hey guys, I hope you were not sleeping while I gave you the task of solving, but obviously you guys are smart people, so you were solving, right? Okay, come on guys. I want more answers. What is your answer? You can see that every answer is different, so it doesn't really make a difference if you have the same answer as someone. Okay, if you were not able to solve it, just tell me like, I couldn't solve it, so please explain. All right, you're not gonna send. Okay, I get it. You want me to solve it. All right, but I'm not going to tell you the answer, right? Because the first thing I want to check is the method, right? All right, now please pay attention. Okay, we got a decent number of answers. Let's start. Now, let's look at the question. Now, be very careful because I assume that most of you were confused here. Mass, right? We have the mass, we have the radius, and we have the gravitational field strength. Now, in my mind, I only have one formula which has all of these, which is G is equal to mg divided by r squared, right? I have the radius, right? I have the radius, I have G, and I have M, and I have G as well, because this is a constant, everyone knows the value, right? Now, this means that this formula is the most suitable as compared to the all other possible formulas. I mean, there's more methods. There's a lot of methods to solve it. Now, let's try to, write our data in more, I mean, in better, I guess, easier terms, right? So mass of the Earth, let's write ME. Mass of the Earth is 81 times mass of Moon. So let's say 81 mm, 81 times mass of the Moon. Radius of the Earth is 3.7 times radius of the Moon, RM. And GE is 9.81. We want to find out GM. Okay, so we want to find out GM. Now, this is our data. Let's take it and let's place it here. What I'm going to do is I'm going to make two formulas. And I have a constant here, right? I have G here. So why don't I utilize this G? And why don't I manipulate this to my use to find what I want to find, right? There's a constant. So if I get two equations, one for Earth, one for Moon, can I just equate them by making G common, right? Let's take out G as our common. Now, let's take G as our common. The first formula is going to be for Earth. G is going to be equal to R squared is going to go up. So let's say RE squared and GE, and M goes down. So M is coming down, ME. Now, let's make the formula, let's write the formula for Moon. It's going to be RM squared and GM and ME, MM. Now, if you got these two, and if your answer is still incorrect, that means you had a calculation mistake. Fun fact, a lot of students, they have the right method, but they have the wrong answer. Oh, nice, Sabina. Seems you figured it out. Okay, let's do this. Okay, now I have these, so why don't I substitute them? First of all, I want to equate them. Now, I know that RE is 3.7 RM, so I can say, 3.7 RM squared. And I know that G is 9.81, right? 9.81. And ME is 81 mm. And I also have the other part of the equation. So it's going to be RM squared GM and finally MM. Now let's square, okay, so yeah, it seems a lot of you forgot to square 3.7 here and Sabina figured it out. That's amazing. Now let's square it and we're gonna get the final answer, which is gonna be equal to, okay, let's remove the ones that are the same here. Yeah, so it's gonna be 3.7 squared, 9.81, and we're gonna have RM squared here and 81 here. And it's gonna be RM squared GM. Okay, now RM squared, it gets canceled out and we finally get GM is equal to this. And the answer you should get is 1.66. So for those who did it, great job, but yeah, don't forget the unit, MS minus 2, right? So minus 1 mark, just kidding. Good job for those who were able to find the answer. Okay, if anyone has a confusion in this question, you can ask me. Okay, is everyone clear about this question? Because this is one of confusing questions in this chapter. Yeah, that's great. I'm glad you know the method. So yeah, be very careful when solving these questions. But what about the rest? Is there anyone who was not able to figure out the method? Okay. Oh, that's amazing. You did it mentally. That's great. Okay, no problem. So I hope you know it now. Note it down if you haven't, and tell me when I can erase this. You can take a screenshot, right? No problem. And I'm going to give you one final question. That's going to be your homework for the other 3 days. It's not a big homework. That's just a small question, right? Just a small little question. Why we equated? Okay, so Ima, GMGE, come on. Come on, G is a constant. You cannot say GM, you cannot say GE. Both of them are the same. G is G. G is 6.6, G is 6.67 into 10 raised to the power minus 11. This is a constant, you see? It's a constant. So yeah, don't worry, no problem. Happens. What? Yeah, no problem. Happens, right? Okay, so I'm about to clear this, and I'm gonna give you one question, which is gonna be your little homework for the weekend. Okay, no problem. I'm erasing this. Okay, I'm gonna write it, and in fact, I'm gonna type it. So it's gonna be your little homework. Just one question. Okay. So mass. It's gonna be again a question about Moon and Earth. So mass of Earth is 81, 81 times mass of Moon. Satellite is launched from the surface of the Earth towards the Moon. So we're sending a satellite towards the Moon, and the distance between the center of the Earth and the center of the Moon is 4 into 10 raised to the power 5. Okay, so this is 4.0 into 10 raised to the power 5 kilometers. Find, there's also going to be a diagram, by the way. You have to find the distance x at which the satellite experiences zero resultant of that zero resultant force as it travels to the Moon. Okay, it may sound tricky, but it's not that tricky, right? This is your question, and let me make a diagram. In fact, I don't think that's needed. Yeah, that's not needed. Okay, it's not needed. Okay, now that's your little homework. Good luck with the question, and yeah, we're gonna discuss it on Monday. If you have the answer, you can send it on the group, but make sure you try solving it on your own before you actually start looking at other people's answers and solutions. All right. Any questions from today? If you have, you can ask, and I guess that's it. So note it down, and when you're done, tell me, and we're gonna end the meeting, okay? Sabina, I just said the diagram is not needed. It's not actually required because all of the info is given in the question. Okay, that's great. So see you all on Monday. Oh, no problem. See you all on Monday, and I hope you guys solve it correctly. And inshallah, next week we're gonna end gravitational fields. So there's gonna be a lot of questions in this chapter. So be prepared, and yeah, Allah Hafiz. Have a nice weekend. Make sure you rest and study, of course. Don't forget it. Okay. Allah Hafiz. See you all on Monday. Bye.